Dear student, this is the Organic Chemistry Part 1. I am starting. In this video, I am going to talk about what is the meaning of homologous series and functional group, how to name the organic compound, and the question based on this lesson. So, what are organic compound? Organic compound means a compound which will definitely have a carbon and definitely they will have hydrogen, okay, and can have other compound. So carbon is a must, hydrogen will be always there, and other compound other element can be like oxygen can be there, sometimes sulfur you can see, sometimes nitrogen you will see like amine group. So there can be other elements also present. Now let's write some of the couple of the example of the organic compound. You definitely heard of methane, which is the CH4, ethane, which is C2H6, and ethanol, which is C2H5OH. You have learned in the fermentation somewhere, definitely in biology also. Methane definitely you have learned in the combustion. So suppose these are the couple of examples which I have written in this board. Now I'll ask you to arrange it. Okay, there's one more. Let's put one more called vinegar, which is acetic acid. Okay. Now if I'll ask you to categorize in certain group, okay, so, like how you will arrange the elements in the periodic table, like group 1, group 2, there's halogen group, because based on the properties, which have the same property we put in the one group and which have different you put another group. So here, if you look this looks a closure group, right? So I can make this is one category, this is two category, second category, and this can be which is different third category. So what is this arrangement? How we are arranging this? This will form a series of compounds. Okay, so it can be further other compound. This also is possible that if you go below this, like how we go in groups. So there is sodium, there is like sodium. Then you have potassium, right? 11, then 19, like that as you go down. So similarly, we can make a series of the compound, in organic chemistry. For example, if you talk about ethanol, there will be further butanol, just add one more carbon, right? Like that. So this kind of arrangement is called homologous series. Homo means same, logos means position. Okay, so here we are putting in a proper series where we are talking about a kind of typical compound. So let's see. um, 1 minute, let me erase this thing. So when you say homologous series, what does it mean? It means that it is a it's a collection of compound with the same general formula. Wait, it is a compound where we have make a collection of the same general formula. Now what is general formula? We are going to talk further in this further next video in detail. They differ only in the chain length, like how we differ in the group, based on the atomic number we differ. So similar thing here, they will differ by the carbon chain length. The compound in homologous series often have a fixed set of functional group, resulting in the which will cause the proper physical and chemical property comparable. Now you'll ask, okay, what is this functional group? So functional group is basically a group of atoms in a molecules with distinctive chemical properties regardless of the other atoms in the molecules. So these are giving you the properties, okay, like alcohol will be different from the acid group and they are linked to each other and rest of the other molecules by covalent bond. Now let's see this thing in a bit detail. Now these are the homologous series. You might have learned this in your textbook definitely. So the series is that here you have alkane series, okay, but the functional group there is no functional formula, but there's and also obviously there's no functional group, but they are suffix called "ane." So whenever you have alkane we say "ane." Homologous series next in your textbook is alkene, which is carbon-carbon double bond. Whenever the carbon-carbon double bond present, that is called alkene, and the suffix what we use is called "ene." Alcohol is the third, which is represented by OH, which is called hydroxyl group, and we write with the ol. Alcohol, ethanol, propanol. Okay, carboxylic acid, the formula is COOH, which is called carboxyl group, and the suffix which we used is called oic acid. Now I'm going to tell you everything in a bit detail. So, how to write a organic compound name? Suppose whenever I write propene, so whenever there's a write propene or ethanol, as you can see here, there are two words. The first, what I'm saying is a prop, right? So prop, it means it is coming first, so this is a prefix. And then afterward, there's another term called "ene." This is the suffix. Similarly, in ethanol, there are two words. If I'm writing ethanol, there are two words, eth and all. So eth is called prefix, which will give you the how many carbon are present. So prefix will always tells you about number of carbon atom. So we have a list of carbon atom. Like if we have meth, we'll say one carbon. Similarly, when you have eth, we say carbon number two. The prop carbon number three. But when you say butane, it means I'm talking about chain number carbon number 4. Pent 5. Hex, hexagon, remember how to remember this part? Hexagon means 6. Hepta means 7. Octa means 8. Non means 9 and dec means 10. Like when you say decade, right? Decade means basically 10 years. So these are the prefix which we use in the organic chemistry. Now talking to the other part of this called suffix, which is the tell you which homologous series the compound belong to. So first will tell you about number of carbon atom. Second will tell you which homologous series you are putting. So they are common suffix what we use alkane when you say it's an alkane group, and "ene" when it is said in the alkene group. When you write all, it means an alcohol group. When we write "oic", like here you have alcohol group, the carboxylic acid. So the suffix, which is the last part, decide which homologous series it is present. Now let's talk about one of the homologous series for alkane. Let's make a compound for around 5 carbon. So if I'm writing carbon 1, let me change the color. So when we're talking about carbon 1, it means what compound I can make. I can make the first compound methane, which is CH4. So alkane formula is basically CnH2n plus 2, which I'm going to talk further in different series about alkane in detail. So this is the methane. If you put carbon number 1, why it is carbon 1? Because we're talking about methane. Meth means 1, so let's put 1 carbon. Hydrogen 2 into 1 plus 2. It means CH4. So this is the alkane homologous series, meth carbon 1. Now if you put carbon number 2, because as I told you we are going to make a series of the organic compound, just increasing the carbon length. So when I putting carbon at 2, let's write the formula CnH2n plus 2. It means C4H6. Carbon number 3, which is called propane. So what it will be? C3H8. Now you can write further like this, C4, it will be your C4H10. If you are writing pentane, which is carbon number 5, it will be your C5H12. So this is the series of homologous series of alkane. You can go on, beyond carbon number 20 or further so on. Now if you look this series, what is the difference you are observing as you go down? So at each step, there is an increase of CH2, right? Like here, you have CH4, now CH6. So if I'll add here plus CH2, it will become ethane. Similarly, where I'm going to move further, 1 minute, it should be C2, not C4. When I'm going to move further from this to this, I will need to add one CH2 here. It will become propane. If I'm going to add further CH2, it will become butane. If I'm going to further add CH2, it will become pentane, right? So as you are going down in homologous series, at each level there is increase in the CH2, or you can say it's increase of the 12 plus 2, basically 14 gram of the mass and weight. So As we are going down, there always increase in the mass, and that's why you'll see different physical properties. For example, the melting and boiling point is going to change, and some other property you can see like flammability can decrease because the Kalman number is increasing further. So what is the characteristics of homologous series? That they will have same functional group, they have similar characteristics, and gradually they will show a kind of physical change as you are going down in the group. So this is the property of homologous series for alkane. Now let's see some of the question based on this lesson. I should expect from this chapter that you should score 100%. So question number one is telling you that the functional group represented in each of the organic compounds. So let's talk about butanol. What do you think? Which functional group? The first, it should be OH. The second, you can pause the video and write the answer and you can match. Is it correct? B should be ene. The C should be oic, means I'm talking about carboxylic acid group. Question number 2 is saying that glycolic acid found in the sugarcane and sugar beet, lactic acid found in the sour milk. Now, the structure formula of glycolic acid and lactic acid are shown below, as you can see here. Okay. So, do you think that glycolic acid and the lactic acid belong to the same homologous series? How I know that? So, same homologous series should have same functional group, right? So now let's see, does they have same functional groups? As I can see here, there's COOH group here, and this also have COH group, correct? This has also OH group, and this also have OH group. So yes, they are in same functional group. They have same functional group, so they will be in same homologous series. Now let's talk about some of the more other question. Question number first, which statement about members of homologous is incorrect? So which is incorrect? Let's talk about all the points. So they have the same functional group. Yes, it is correct, right? They undergo similar chemical reaction. Yes, they are, because if the functional group is same, it means they will behave similarly. Like group number one, how they behave, they will react same way. Option number three. So as you can see here, option number D is the only incorrect option because they have written same number of carbon. That is not possible because series means what? As you're going down, carbon number is going to increase. Now let's see question number two. Glycerin is used to as antifreeze in the car radiators. In the winter season, formula is glycerin is this. Chemical property of a glycerin is structure similar to the part of what is this called? Alcohol group. So it will be option number C. Question number three. Which of the following organic compound correctly matched with this formula? So ethene. Remember ethene, what we have learned, it is CnH2. I didn't taught you, maybe next class is H2N. So ethene is yours here. Propane is the C3H6. No, no, ethene is the C2H4. No, it is not matched. It should be C2H4, right? It's not matching. Methanoic acid, not correct. Methanol is the only correct option. Meth means carbon number 1 and then put the functional group OH. Write all the hydrogen in play in the all other bonds. So option number C is the only correct option we have. Now let's see question number 2. Which of the following pair of the compound belong to the same homologous series? It should have same functional group. So this is not, because here carbon number 1, here carbon 2, not possible. This is carbon number 2, carbon number 3, not possible. Here you have OH, here you have OH. So yes, this is the group. Here you have OH, but remember this is not OH because this is one functional group called COH. So option number D is the C is the only correct option. So I hope this is all correct for you. Whenever you write any organic compound, always start first functional group. For example, if I'm writing alcohol, I'll write first alcohol. Then you start with the carbon. How many carbon? For example, when you write methanol, I'll just write carbon number 1, just one carbon, and rest you just filled with the hydrogen. Remember, always carbon has always 4 bond because carbon is a tetravalent compound. So always make a 4 bond. So rest you just make with the hydrogen, and then you can write the formula. So it will be CH3OH, like that. When I am writing ethanol, eth means carbon number 2. So just write carbon 2, and then you write all means functional group OH, and then rest you adjust with the hydrogen. So the formula will be here C2H6OH. Maybe I can practice some of the more with you in the next lesson. So thank you so much for watching.